I want to just interject here with a few facts about binomial coefficients. So binomial coefficients are the quantities that we were working with before, where it was n choose k. Okay, and so there's a few things that I want to talk about. So the first is I want to explain just intuitively why 10 choose 4 is the same as 10 choose 6. Of course, you could check that the formulas work for all these values. 10 choose 4 and 10 choose 6 are going to be the same number because the way that you compute these, 10 choose 4, is you have 10 factorial over 10 minus 4 factorial divided by 4 factorial. And so you get 10 factorial over 6 factorial times 4 factorial. Fine. 10 choose 6 is 10 factorial over 10 minus 6 factorial, which is 4 factorial times 6 factorial. So the order of the multiplication gets switched, but it doesn't matter. They're the same value. So these are, of course, algebraically the same. But that's not what I mean when I say I want to talk about why they're the same. I mean, I want to intuitively understand why should these be the same. And so what I want to do is I want to think about having a group of 10 people. Okay, so you have let's say 10 people. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And maybe I should have given these names actually. So let me take that back. And let's just call them person A, B, C, D, E, F, G, H, I, J, K. So here we have 10 people. And is that 10 or is that 11? I still can't count. What are you going to do? It's 11. So we have 10 people. And what we want to do is we want to choose 4 of them to go on a trip. So maybe we want to choose 4 of them to go give a talk to a client or whatever. How many ways are there to choose 4 people to go on a trip? Well, you could choose, for example, B, D, H, and I, right? That's one choice that you could make. And counting these is a pretty laborious process, but we know that the number of 4-person teams, so the number of 4-person teams to go is 10 choose 4. Okay, so that's 10 choose 4. So the number of ways to pick 4 people out of this team to go give a talk to a client or whatever is 10 choose 4. Now, I could think about the dual problem. Instead of thinking about who goes to give the talk to the client, what I could think about is who's not going to go talk to the client, who's going to stay back. And so how many ways are there to do that? Well, what we're going to do, let's get rid of the highlights here. What we're going to do, if we want to choose the number of people not to go give a talk, that's going to be 10 choose 6. So the number of 6-person teams is 10 choose 6. So deciding who gets to go is the same as deciding who stays back. Okay, I don't remember what choice we just made about who got to go, but the point is that deciding who doesn't go is the same as deciding who goes. You're just kind of deciding the dual problem. Okay, but the number of ways to do each of these should be the same, right? The number of ways to make a 4-person team is the same as the number of ways of picking 6 people not to be on that team. Okay, so that's just intuitively why these should be the same. Okay, so this is a little binomial coefficient stuff. The other thing that I think would be really useful when working with these binomial coefficients is to be able to compute some values by hand, namely some small values. So if you were to compute, let's look at 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Okay, so just by the formula, this is 3 factorial over 0 factorial times 3 factorial, and that turns out to be 1, because remember that 1 factorial is 1 itself. So the reason for this is actually so that these formulas work out. I'll talk about that in the end. 3 choose 1 is going to be 3 factorial over 1 factorial times 2 factorial. 3 factorial is 6. 1 factorial is 1, 2 factorial is 2, so this is going to be 3. 3 choose 2 is going to be 3 factorial over 2 factorial times 1 factorial. So again, that'll turn out to be 3. And 3 choose 3 will be 3 factorial over 3 factorial times 0 factorial, which is 1. So let's think about this case in particular, this 3 choose 3. If I have 3 people and I want to make a 3-person team, how many ways are there to do that? Clearly, there's one way to do that. You just pick all the people. And notice that this actually gives us a good reason for why 0 factorial is 1. Because if 0 factorial was anything other than 1, then this number would be not the one that we want. So it's a little bit tricky here, but the 0 factorial is defined so that these numbers work out nicely and so that they kind of match up with our intuition, right? How many ways, if you have 3 people, how many ways are there to make a team of 0 people? Well, there's one way to do it. You just don't pick anybody, right? So there's only one way to do that. Likewise, if you have 3 people and you want to make a 3-person team, there's only one way to do that. You just pick everybody. So these 0 factorials are there so that these formulas work out. At least that's one way to think about why they should work that way.